last electron out. Clear? Good. Now, let's talk about Fe. What's the electronic structure for Fe? Which is 26. Or let me take something else. Let's talk about, so that we have something different. Let's talk about titanium. What's titanium? What's the number of titanium? Look at the periodic table. Ti, what's the number?
22.
What? Hello? What's the atomic number of titanium?
81.
22.
22. 22, sorry. I wrote 23. So yes. Good. 22. Good. Okay. Can you write the electronic structure? 1s2.
1s2, 2s2, 2p6.
Yes.
3s2.
3p6. 4s2. 3d2. Clear? That's the electronic structure. Now, if I want the electronic structure of Ti, Ti titanium 2+. What's the electronic structure? It will be the same. 1s2, 2s2, 2p6, 3s2, 3p6, and then
Delete the 3d2.
what?
We'll cancel 3d2.
No, that's what I want to say. In transition metal, you delete the 4s electrons, and then this will be 3d2, and you get rid of 4s2 always before you take from D. Is this clear? Is this clear?
Why?
That's the property. There is no why, actually, no reason. Now, if I want to have the electronic structure of titanium 3+, then what would be the structure? Again, quickly. 1s2, 2s2, 3p6, 3s2, 3p6, and then 3d1. Now I have to take from the D. Is this clear? Now, I want to tell you this information even if you have titanium +1, okay? The structure is, hello?
Yes.
1s2, 2s2, 2p6, then 3s2, 3p6, and then 3d3. Tell me what happened.
We took one electron from 4s2 and give it to 3d.
Exactly. So all the electrons either gone when you have ions. Either the electron will be gone, or it will be transferred to titanium plus. Clear? Okay, good. Last thing, look at this one. This is iron, which is argon 4s2, 3d6. When we have iron 2+, where are we going to lose the electrons from?
For us.
4s, and we take the 2 electrons. All right. I want you to tell me what's the electron structure for Fe plus. What is it going to be? argon, and then
3d7.
3d7. Exactly. Is this clear? Is this clear? Good. I hope so. Let's finish this.
If there is an element and the D becomes full, should we start with forest?
And then the D become what?
Full.
Yeah, of course. Whatever. I mean, oh, good. Let's assume that we have. Of course. Oh, yeah. If it's plus, you mean +1 only.
Yes.
Yes. Then you have to fill with the forest. You have no choice. خلاص. Oh, good question. But then the 3D is full. If it's full, خلاص. You have to fill to put in the S. Exactly. Like in the example of zinc plus, which does not exist, by the way. Zinc plus, if you want to draw the structure of zinc plus, it's argon. And then 4s1, 3d10. Why? Because the D is full. And now I don't take from the D, I take from the S, and I will be left with 1. But this element, this ion does not exist. Actually, the one which exists is 2 plus, and this way, if it's 2 plus, then there will be no 4s at all. Clear?
Clear, thank you.
Very good. All right, with this, we finish chapter 7 completely. Don't forget that we did not, what's omitted from chapter 7?
7.7.
Exactly. I want you to know this. Keep it in mind. Good. Done. Okay. By the way, are the lectures, are you recording the lectures or nobody is recording the lecture?
No, you are recording, so.
Not recording.
I'm not always recording. That's why I'm asking. Anyway, it's up to you. Let's go to then chapter 8 right away. And then, what's the title? Chapter 8. Read the title.
Chemical bonding.
Chemical bonding.
Basic concepts.
Basic. What's the meaning of chemical bonding?
رابط الكيميائي.
Yeah. What is it?
رابط الكيميائي.
Yes, الرابطة in Arabic. What's the meaning of chemical bond? We have 2 important bonds, only 2 important bonds. What are these bonds?
Ionic and molecular.
Not molecular.
Or covalent.
Covalent bond, yes. We have ionic bond and we have covalent bond. All right. How is the ionic bond is made?
By non-materials.
Oh, first, yes, that's.
Metal and non-metal.
Ionic bond take place between metal plus non-metal. But covalent bond between what?
Non-metal.
Metal and
Non-metal.
non-metal. Okay, how does the ionic bond take place? Transfer of electron from what? Metal
From metal to non-metal.
to non-metal. But covalent bond take place by
Sharing
Every,
electrons.
Sharing.
sharing electrons. All right, and that's why in ionic bonding, like if you have NaCl, Na and Cl, one electron will be lost. This is electron goes away from sodium to chlorine. When it goes away, what will happen to sodium? It will be sodium what? Plus. And if you give the electron to chlorine, what will be the charge of chlorine?
minus.
And then what will happen between them?
Bond.
A unique bond.
There will be what? Attraction.
Ionic bond.
And this is the ionic bond, but there will be attraction. It's like you can think about it as magnets. Two magnets come together. Is this clear? This is called ionic bond. You have to keep it in mind. Ionic bond. While in covalent bond, it's different. It's sharing of electron. If we have hydrogen with one electron and hydrogen with one electron, they will share this two electrons, and we usually draw them by a line like this. And this shared electron will be between both hydrogen. So they are shared. When we draw, by the way, when I draw a line like this, what does it mean? It means what? Two electrons.
Bond.
It's a bond and it's two electrons. Okay, how about if I draw two lines like this? What does it mean?
4 electrons.
Four electrons. How about if I draw three lines like this?
6.
6.
And there are 6 electrons shared between the two nonmetals. Is this clear? So when I draw H dash H, what do you understand? That there is two electrons what? Shared between the hydrogen and the hydrogen. But when I draw, how do you read this bond?
CO3.
CO. Okay. How many bonds are between carbon and oxygen?
3.
3 bonds. How many electrons are shared between carbon and oxygen?
6 electrons.
6 electrons. Because there are other electrons, like for example, there will be 2 electrons here and 2 electrons here. We are going to call this pair of electron pair. What pair means?
Zouj. Couple.
2. Pair means 2. Okay. And we are going to call them unshared. Unshared pair. So what are we going to call the bond? Share pair. What do you mean by share pair? Hello?
They are sharing the electron.
Two
Both
electron
Sharing.
sharing.
hydrogen are sharing the electron. When I say unshared pair, what does that mean?
Are not used in
They belong,
the bond.
yes, not using the bond, and they are belong to one atom. So in this case, this pair, what do you call it again?
Unshared pair.
Unshared pair.
And this one,
Unshared pair.
and these 3 together, what do you call them?
Shared pair.
3 shared pair. Is this clear? 3 shared pair. Very good. Excellent. That's me. Now, first thing I will talk about is called Lewis dot symbol. What is it? Lewis dot symbol. Do you remember resonance? Valence electrons. What's the meaning of valence electron?
Not the core.
What?
The electrons on the last outer shell.
What's outer shell? Which outer shell? Last
SP.
SP electron.
The last level.
Last SP electrons, in particular SP. Good? Okay. What do you call the other electron which are inside?
Core.
Core electrons. Good. Now, I want you to remember the word valence, very important. Valence. Okay, where is your periodic table? You have your periodic table with you?
Yes.
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 Can you put the number of valence electrons in the groups? You remember that?
Yes.
Can you do it? If you do it, this is now the main group. What's the valence of the first group, which is this group? What's
Plus
the valence?
one.
What?
+1.
This one.
+2.
Not plus. The valence is 2. Yes, I
Two.
want it. It's not plus or minus. It's the valence is the number of electrons. The number of electrons, the last S is 1, 2, and here in this group 3, and then in this group
4, 5, and 6.
4,
then
5, 6, 7, 8.
forget this. You have to, very simple. I mean, this is not memorized. You have to know it. Have your periodic table with you and put these numbers. All right. I want you now to know what the meaning of Lewis dot symbol. Lewis dot symbol. What Lewis did, he took the valence electron and distribute in 4 groups. Okay, so what Lewis did, he took the valence electron and he put 1 dot to say there is 1 valence bond, 1 valence electron. And this one is how many? In this element, for example, how many valence bond? How many valence electron? How many valence electrons?
2.
2. Look how Lewis do it. This is the structure of Lewis. He put the 2 electrons like this. Okay. When you go to, for example, indium, what's the valence of indium? What's the valence?
3.
3. Look at how Lewis dot symbol is done. All right. Very good. Now, how about phosphorus?
4. No, 5.
Oh, sorry, I don't do 5. Fine, fine. 5, 1, 2, 3, and then 2 together. Look at Silla or GE. How the structure is done.
4.
Very good. How about phosphorus? 5. How about Se? 6. How about bromine?
7.
7. How about neon?
8.
I want you to be able to draw the Lewis structure for any element like this. Look at your periodic table, and now I want to. Did you memorize it very well? I mean, you don't have to memorize it. I want you to look at your periodic table, and you should be able to do it for any element. Is this clear? Any questions?
Yes.
Is this?
What about group 3 and 4 and 5 and 12?
Yeah, it's very simple. You have to know. You have to, of course, I don't, as I said, I don't want you to memorize. I want you to write this in your periodic table. This is 1, 2, 3, 4, 5, 6, 7, 8, and then distribute them so that you have 4 groups like this. 4 groups, don't forget. And if there is 1 electron, I'll put 1 electron. 2 electrons, I put 2 like this. 3 like this. 4 like this. 5 like this. 6, 7, 8. As simple as that. Now, let me ask you a very simple question. If I don't have any electron, like for example, if I have K plus, then what's the lowest structure for K plus?
2.
What's the
0.
how many electrons in the lowest structure should we put?
Nothing.
Nothing.
Exactly. Thank you. Nothing. No nodals. Very good. How about assume that we have Al plus? We don't have this, but let's assume that we have Al plus. Then what will be the lowest dot symbol?
1.
2.
2.
What? How many? 2. Where should I put them?
On the right.
Right and left.
Right or left, or even if I put
Or
them
up and down.
there is no problem. Is this clear? Good. Let's assume that, as I said, this element does not exist. So I will erase this because it's not a good example. But let's have something like, for example, chlorine 3 plus. Chlorine 3 plus. Let's assume we have this one. All right. How are you going to draw the lowest symbol?
1 dot.
4 dots.
Just
4 dots.
Where should I put the 4 dots?
Anyway.
point at each side.
Exactly. Is this clear? All right. Now, how about if I put Cl 5 plus? Yeah, let's assume 5 plus. Let's assume.
2 dots.
Where should I put the 2 dots?
Left and right.
Doesn't matter. Can I put it this way? Yes.
Yes.
Can I put it this way? Yes. Anyway, left and right, up and down, both sides, any sides, no problem. I hope this is clear. Good. Now, very quickly answer this question.
Doctor, is it okay to put the dot at the same side?
No. Well, you can, but usually no. You can actually. It's not wrong if somebody did this. Cl 5 plus like this. It is okay, but that's not preferred for dot Lewis symbol. When we do it for something else, but when you say dot Lewis dot symbol, we prefer. This is not wrong. It's not wrong. It's okay, but not preferred. The best thing is actually X or any, as I said, any plus. Clear?
Yes.
Like the Lewis structure for K plus. Quickly look at your periodic table and write it.
Okay.
Without dots?
Yes.
Excellent. How about F minus?
Eight.
8 dots.
Where should I put the 8?
To each side.
To each side.
How about F minus?
To each side.
7.
7?
8.
8, not 7. Who said 7? Look at your periodic table one more time. What's the valence of sulfur?
6.
6.
6. And you have 2 extra. This means what? Total what?
8.
8. So yes, the lowest is like this. Very clear. Any questions so far? Now, we'll talk about now lattice energy, and we'll talk about the Born-Haber cycle. Lattice energy and Born-Haber cycle. I want you to know that lattice energy, we will refer to it in this chapter or in this book course as capital U. Capital U letter. So write this. Lattice energy is a capital U letter. Okay, I will tell you now what is the lattice energy, and I want you to write equation to represent the lattice energy for something like MgO. Okay, if we have MgO, all right, I want you to write the lattice energy. Listen to me as I talk, and then write in your, use a pen and so on, write, because I want to ask you after I finish what's the equation that you write. The equation for lattice energy that represent lattice energy is, I will say this, lattice energy is the energy required. So at the end, we're going to have delta H because it's energy. Delta H is enthalpy. Delta H for this reaction. It is the energy required, and delta H in this case equal to U, which is that's energy. It's the energy required to take a solid compound. So what should I write here?
Yes.
Yes, sir.
Yes.
It's energy required to take a solid compound into gaseous ions. Gaseous ions. So I want you to write, to complete the equation. Go ahead and write the complete equation.
Mg plus G
Mg what?
in gaseous state
Plus 2.
plus
Yes. Mg2 plus what?
O2 minus.
O2 minus
O2 minus what?
gaseous state.
Excellent. Is this clear? Again, I will repeat the meaning of lattice energy. The lattice energy is the energy required to take a gaseous, a solid compound into gaseous ion. Into gaseous ion. With this equation, lattice energy is always what? Is it positive or negative?
Positive.
Positive or negative? Come on.
Positive.
Positive. Generally, when you break bonds, then it is always positive. When you make bond, then it is negative. Is this clear? So you have
Doctor.
between Mg and O, so this is always positive. Always. Very good. Now, tell me what's the energy required for this reaction? Mg2 plus gas plus O minus gas to make MgO solid. What's delta H for this reaction?
Minus
Minus U.
Excellent. Minus U. You have to keep this in mind. So it's not minus. The U is not. It's always positive. But this, we put the minus because we reverse the reaction. Here. Okay. Now I want to take you. Before I go further, I want to take you to. Well, let's stop here.
Doctor.
Yes.
Does the magnesium corrode via the oxygen?
No, we have no. It is the corrosion between iron and oxygen is actually the reaction between Mg and O. But this is called corrosion because it is bad for iron. When this compound is made, it's not bad. So in fact, this is a side issue. But aluminum also react with oxygen, make Al2O3, okay, like iron. But here, this is solid. This is not corrosion. Aluminum Al2O3 is stronger than aluminum. So when this happens, then it becomes like a cover for aluminum, so to protect aluminum. But for iron, Fe plus O2, this is a side issue, will give you Fe2O3. This is not, it is solid also, but actually very brittle solid. Brittle. Smart brittle. What's brittle means?
قراق يعني.
يتكسر. ما هو قطعة واحدة. So that's the corrosion. Does this answer your question?
Yes, thank you.
This is a side issue. I'll take it away again. Now, we've done with this. But I want you, again, to understand the lattice energy very well. What's the meaning of lattice energy?
Energy you need to break solid compound to ion gases.
Solid compound into gaseous ion, gaseous ions. Good. That's the lattice energy. That's what's delta H here? What's this number? 632. What's the other name for it?
Lattice energy.
You
lattice energy.
Lattice energy, which is what? U. This lattice energy has been counted for many elements, many compounds. Okay? And this table here show you the lattice energy. All right.
Doctor,
Yes. Hello.
talking about ionic solids, right?
Ionic compound, yes. All of this is ionic bonding. When we talk about ionic bonding, which is between what? Ionic bond between what and what?
Metal and metal.
Good. Look at this number. Don't memorize this number. Don't memorize this number. Okay. Before we go further, do you remember what's the energy if we have two ions together? We took this in chapter, I think, chapter 5 also. It's proportional to what? Q1 times what? Q2
over D square.
We divide by what?
R square over D.
D squared.
Distance.
Distance squared, yes. Not R, but distance, D squared. You have to remember this. All right? Keep this in mind. Now, I want you to tell me, as I said, look at these numbers, don't memorize them, just listen to me and answer me. What's the, if we have lithium fluoride and potassium chloride, what is the charge in lithium?
Plus
Plus what? 1 or 2?
one.
Plus one.
What's the charge in fluorine?
Minus
Minus one.
What's the charge of K?
Plus one.
What's the charge of Cl?
Minus one.
Okay, good. Look at the numbers of the lattice energy. What's the number here?
1017.
What's the number here?
699.
Why is this higher?
Maybe because we have fluor.
No, that's not the reason.
Melting point.
What?
Melting point.
No. Why the lattice energy is higher? Look at the equation, answer from the equation. What's Q1 and Q2 for lithium fluoride? What's Q1 and Q2? Right?
Yes.
D squared. How about for potassium chloride? What's Q1 and Q2 for potassium chloride?
Same.
What? 1 and 1.
What?
Right? Excellent.
Yes.
Why this one is higher?
The distance is smaller.
Why the distance smaller? How come the distance smaller?
The periodic table or?
Yeah, from the periodic table. Look at the periodic table and tell me why that this. Yes, absolutely. The reason is that the distance is less.
Because the number of electrons.
No. What's the size of lithium?
Doctor, when you go down in the periodic table, the distance will be
exactly
higher than.
When you go down, what will happen to the distance?
Will be more than
radius of the.
If this is lithium, then this is maybe potassium. How about fluorine and chlorine?
Smaller.
Fluor, then fluor.
And chlor is like this. Then what? This is the distance. In the case of chlorine, this is chlorine, and this is fluorine, for example. And this is the distance for fluorine and lithium. Is this clear? So which one will have less lattice, more lattice energy?
Bigger one.
What?
lithium fluorine.
Lithium fluorine. Right. Let me tell you this now. Let's compare lithium fluoride, lithium iodide with sodium iodide with potassium iodide, Ki. Which one will have the highest lattice energy?
Lithium iodide.
Fantastic. Why?
Because when we go down in the periodic table, the size increase, the distance increase.
Excellent. So look at this. Which one is the highest? This is the lattice energy of lithium fluoride, lithium iodide. This is sodium iodide and potassium iodide. Can you see this? Is it easy?
Yes.
Let's compare lithium. Lithium oxide, lithium chloride, lithium fluoride. Let's say lithium fluoride with Mg. No, not good. Let's compare sodium fluoride with Mg oxide. Which one you think will have higher charge? Assume that the size is the same. Assume that the size of sodium and Mg is the same and fluoride and oxygen is the same. Assume it's not they are exactly the same. So the distance is almost the same. Which one will have higher energy? NAF or MgO?
Na.
What?
MgO.
Why is that?
Because there is 4 charge in the numerator.
What again?
4 divided by number and 2 divided by number, 4 will be bigger.
Again, I cannot hear you. One more time. Hello?
We
Doctor,
will divide the charge by the distance, and the distance is the same. So if we
Same,
have
yes.
4, will be bigger.
Fantastic. Let's assume that the energy, the U for NAF is X. Then what do you expect the energy for MgO?
for you,
What?
for you.
Exactly. Is this clear? Yes. Let's assume, look at this one. Look at this one. Assume that the distance is the same. Lithium fluoride and MgO. Look at the numbers here. What is it?
$1,070.
And this number. This number. What's the relation between these two? Almost 4 times. Can you see that? Fantastic. Okay, arrange the following in order of increasing Lux energy. Which one had higher Lux energy? Which one has the highest? Look at your periodic table.
MgO.
SRO.
SRO.
MgO is what?
The lowest.
The lowest?
The highest.
RO.
Highest. Greater than what?
Greater than CaO. Then
CaO.
greater than CRO.
SR. Excellent. Is this clear? Yes, absolutely right. And this is the way, because the size make difference. Or reverse. Now, Born-Haber cycle. And I want you first write the name. Born-Haber cycle. Born-Haber cycle. And memorize the name. Like what we did with Lewis dot symbol, I want you also now to memorize the Born-Haber cycle. Good. Next. Go to this thing, and then we'll talk about what's Born-Haber cycle. I want you to make definitions for me. First, assume that we're going to talk about this particular example, which is we're going to talk about Cl, Cs, Cl. We're going to talk about CSCl compound. So all our concentration is CSCl compound. Good. If I want you to write the U for
Doctor.
Doctor, you are muted.
You can't hear you, Doctor.
what is U? For CSCl, if you have CS, hello?
Yes, yes.
Yes, we can hear you now.
What was the problem?
It was muted.
Okay. What's CSCl? Solid. What's U? Write equation to represent U.
Minus 400.
What? What's that energy?
Cl minus
CS plus what?
Gas.
Plus
Cl minus
Cl minus. Yes.
yeah, exactly. All right. Okay. I want you to write equation to represent. You, by the way, before I go further, what's the meaning of heat of formation?
The energy required to form a bond.
No, what's heat of formation?
Natural occurring.
From naturally occurring things. Yes, exactly. Okay, good. What's the heat of formation of CS gas? What's the heat of formation of CS
Zero.
gas? No. Heat of formation. Heat of formation of CS solid equal to 0. Heat of formation of CS gas. Can you write equation to calculate heat of formation of CS gas? You take CS solid and change it to CS gas. This is heat of formation, delta H, formation of CS gas. Is this clear?
Doctor.
Now, if I write, so what's the value for this one?
76.50.
76.5. Exactly. Good. Good. Next, what's this equation? CS gas goes to CS plus gas plus electron. What's this? Equal to?
Lose electron.
What?
Lose electron.
Yeah. What's the equations called?
It's the IE or
What's the?
I forgot the
first ionization energy. Can you read it now? First ionization. And what's
ionization
this?
energy.
What's this equal to what?
376.
376. Good. Next. What's the heat? Right equation to represent heat of formation of Cl gas. What's the heat of formation of Cl gas? Can you write it?
349.
First, you have to take it. I want to write equation. Cl2 gas goes to what?
Goes to Cl.
Gas.
Yes.
And I write half. Why did I write half? Because I want always the heat of formation should be 1 mole. And that's why we have 1 mole in here and 1 mole in here. So what's delta H for this reaction now? I want number from the table. What's the heat of formation in this case?
121.7.
Exactly, 121.7. 121.7. Excellent. Okay, next, if I take Cl gas and make it Cl plus, of course, plus electron to make Cl gas, Cl minus gas. What's this energy called?
EA.
What's A? EA1, what's the meaning?
Oxidize.
First electron
Electronic affinity.
affinity. You have to memorize these names, very important. First electron affinity. What's the value?
349.0
exactly. Last equation. If I have CS solid plus half Cl2 gas to give me CSCl solid. What's this equation? Last equation is called?
Heat of formation of CSCl.
Exactly. We're making the compound from the original compound, which are these, and that's why delta He in this case equal to what?
Minus 442.8.
Minus, listen here, minus, oh, I made a mistake. I will come back to this one. Okay. This is minus 442.8. Don't forget this. Okay, there is a mistake I made and nobody noticed. What's this? Electron affinity, right?
Yes.
Electron affinity, first electron affinity. And what's the value?
$349.
When I want to make it delta H, what should be the value?
Divide by 2.
No.
Minus the electron affinity.
Minus the electron affinity. That's why, of course, in this case, no need to divide by 2 or anything because it's 1 to 1. So this should be also minus. It's minus electron affinity, and that's why it should be minus 349. Do you remember his law?
Yes.
Okay, good. I hope you remember it. Look at these equations together, add them together, and you will get to this one. I want you to calculate U. Go to your calculators now and calculate the value of U. Whatever you need to cancel together, cancel, so that at the end you have the value for U. Maybe you need to reverse one of the equation or whatever. You need to reverse the last equation, actually. Only the last equation, reverse the last equation, and then cancel things together and give me the value for U. Of course, when you reverse an equation, what will happen to the delta H?
Change the sign.
Exactly. Go ahead. As I said, reverse the last equation and cancel anything by his law, cancel anything available in both reactant and products. Go ahead. And then tell me what's the value for U.
Is it 668?
Fantastic. Super. Who did this?
Me.
It is 668. So U actually is U. Oops. It is 668. I hope you were able to calculate it. It is 668 because that's how you do Born-Haber cycle. This was done, actually, this is for something else, for sodium and chlorine. Look at here, it is like a cycle, and that's why we call it cycle. It's the same thing that I did just a while ago, but look at how beautiful he did it so that it is a cycle. I want you to remember Born-Haber cycle. Born-Haber cycle. This is how we have everything now written one by one. Each reaction goes to the next reaction and so on and so forth. All right. And these are actually, these reactions. And usually in the exam, I will give you these values. Not, maybe I'll give you this one, or I'll give you and ask you to find something else and so on. So usually I will give you all the, I'm not going to give you reactions. I will give you only values like this, and you should be able to write the equation, and then when you write the equation, calculate the value for this reaction. Is this clear? Any question? What's the name of this process?
Born-Haber cycle.
Born-Haber cycle. Don't forget the name. Born-Haber cycle. Okay, I hope you know it. Good. Done. Now, Lewis structure. Lewis structure. What's Lewis? First, what's the meaning of Lewis dot symbol?
You're representing the valence electron by dots.
Exactly. Fantastic. Super. And that's why if I want you to write the electronic structure for S, what's the dot symbol for S? Use your periodic table.
It's 6 valence electron. So dots every side.
2, 3, 4, 5, and 6. Yes, that's the meaning of dot Lewis dot symbol. Okay, how about okay, good. Next, let's assume I have GA. Hello?
Yes.
It's 3.
1, 2, 3. Very good. Let's assume I have bromine.
7.
1, 2, 3, 4, 5, 6, 7, and so on and so forth. Is this clear? Now, when non-metal plus non-metal come together, all right? What do we call this bond?
Ionic.
No. Non-metal with non-metal.
Covalent.
Covalent bond. Covalent bond. Now, when hydrogen come with hydrogen, they will make covalent bond like this. Okay? And they will have only 2 electrons in between them, and they cannot take more than this. Other than hydrogen, the elements would like to have 8 electrons around them. Other than hydrogen, hydrogen takes hydrogen atom, take only 2 electrons around. But other atoms would like to have 8 electrons around. Clear? How? Let's take 2 elements. Like, for example, let's take chlorine with chlorine. Okay? Tell me what's the dot symbol for chlorine?
7.
1, 2, 3, 4, 5, 6, and 7. How about this chlorine?
7.
1, 2, 3, 4, 5, 6, and 7. Good. Each element would like to have how many electrons around it?
8.
8. By sharing the electrons together, these electrons now are belonging to both chlorine. How many electrons around this chlorine?
8. 8 electrons.
Chlorine?
8 electrons.
Excellent. For hydrogen, how many electrons around this hydrogen?
2 electrons.
This one?
2 electrons.
Let's give some other example. For example, if I take oxygen and oxygen, and I have, what's the dot symbol for oxygen?
6.
1, 2, 3, 4, 5. Sorry. Okay, 1, 2, 3, 4, 5, 6. Okay, usually we don't draw it like this. We have to have each one by itself, but I will do it this time like this. 1, 2, 3, 4, 5, 6. How can you make them 8 around each other?
2 sharing electrons.
By sharing these and these, right? This way, how many electrons now around this oxygen?
8 electrons.
8.
Can you do it for nitrogen and nitrogen quickly?
5 and 5.
We have how many? What's the dot symbol for Lewis?
5.
For nitrogen. 4? No.
5.
5.
5. Listen here. 1, 2, 3, 4, 5. How about this nitrogen? Same thing. 1, 2, 3, 4, 5. You will say, why did you draw it this way? Well, I want to have 8 around each one. How can you make them 8 around each one?
3 sharing electrons.
3 sharing electrons.
2, 3. And now, how many around this nitrogen?
8 electrons.
And this nitrogen?
8 electrons.
Fantastic. Now, let's do it for like C and O. Okay, put the Lewis dot symbol, get a paper and write what's a dot symbol for carbon.
4.
And for oxygen?
6.
6. How can you make them 8 around each one?
We can't.
You can't?
Yes.
I will put 2 here, and I put them with X's so that we know that these belong to carbon. Carbon. How many are left? 2 here and what? 2 here. Good? I put X so that we know that these X belong to carbon. How about oxygen? What do you have?
6 dots.
2, and then 3, 4, but I need more. If I put only 2, I'll keep the other 2 for oxygen for a while. They are there. These are the 2 electrons for oxygen. I'll keep them away at this time. Now, if I put only this bond and this bond, then how many are on the carbon?
6.
Only 6.
6.
How about the other oxygen? The oxygen. Only 6.
Yes.
I will take these 2 together, these 2 electrons, and I'll put them also here. Now, how many around the carbon? And how many around the oxygen?
8.
Is this clear? Is this clear? Any question? Can you do that? So we can use the electrons from one element as shared between two other elements. See, these are the X's are the electrons for carbon, and we use them, all of them, but we also use 2 electrons from oxygen to be shared between the carbon and the oxygen. Is this clear? Any question?
Doctor,
Yes.
from where we got this last electrons?
It's from oxygen, as I said. Oxygen has how many electrons?
6.
Let's do it one more time. Take care of this. Listen to me now. Okay, let's write the lowest structure for carbon. I write X, 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 X. How about for oxygen? Oxygen, 1, 2, 3, 4, 5, 6, right? Then I bond this with this one and bond this with this one with this one. If I do this, now how many electrons around the oxygen?
8.
8. How about carbon? How many?
6.
6. Is this acceptable? It's not acceptable. So what did I do? I took these 2 electrons and they are in here. I'll shift them from here to here to put them here. Is this clear? So I took them from here and put them here. Now, how many around the oxygen?
Oh, 8.
And how about the carbon?
Also 8.
Is this clear now?
Yes, it's clear.
Now, let's assume that we have C, O, and O. Can you draw the Lewis structure quickly? I want you to help me and draw the Lewis structure. Don't forget, write the symbol for carbon and for oxygen.
2 bonds between carbon and the 2 oxygen.
This is 4 for carbon and 6 for oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, do it 8 around each one.
Oxygen share 2 dots with the carbon.
Like this.
And carbon share 2 dots with oxygen, another oxygen.
Yes. Now, how many around the carbon?
8.
8.
Excellent. How about oxygen?
8.
Excellent. The other oxygen?
8.
Excellent. Fantastic. Super. Okay, let's go one further question. I hope this is clear now. Okay, now let's go to NO minus. The whole thing is minus. This means we have what? Extra electrons. Extra 1 electron. Okay, put the Lewis symbols for each one.
And 5 dots.
Okay, put it. You do it yourself. Do it in your paper. Then, don't forget that we have, I'll help you. I'll put 2 electrons here. Again, the other this is oxygen, but this one, I'll put one electron here, one electron here, and one. All right, and then we have one electron here also. Oxygen is dot. So and then yes, are you able to do it?
Yes.
Okay, let's see. You will find that you need to bond this one with this one, and only one bond here, and one bond here. We use now the 1, 2, 3, 4, and then we have extra electrons in. Okay, so we use only 4 electrons from the nitrogen. How about oxygen? So what did I do? Okay, listen to me now. I'll deliberately put here listen to me. All right. How many around? How many? What's the Lewis dot symbol for nitrogen?
Eight.
Huh? Dot symbol.
5.
5.
2, 3, 4, and 5. Yes, excellent. So listen to me. The nitrogen now, I use 1, 2, 3, 4, and 5. These are the 5 for nitrogen. I put this one shared between the oxygen and the nitrogen. Is this clear? Okay, what's the dot symbol for oxygen?
6.
6.
I have a count here. How many? 1, 2, 3, 4, 5, and 6. How about this oxygen? 1, 2, 3, 4, 5, and 6. So everything's okay. How about this oxygen here? We have 1, 2, 3, 4, 5, and 6. How about this electron? From where we bring this electron then? From the minus charge. And that's why I put it as a circle so that it's different than the other ones. Now, count how many electrons around nitrogen?
8.
8. How about this oxygen?
8.
8. How about this oxygen?
8.
8. How about this oxygen?
8.
This is how to draw Lewis structure for molecules. I want you to know how to draw Lewis structure. And from this, you'll find if there is single bond or multiple bond. What's the meaning of single?
One shared
How
electron.
about multiple?
More than one.
2 pairs.
2
So,
or 3.
so is this, and this compound, is it multiple or single bond?
Multiple.
What is it? What is
Triple.
it? Triple bond. How about this one? Triple bond. This one?
Triple bond.
No.
Double bond.
Double. This one? double. This one, single. This one,
double,
double. This one,
single,
Single.
this one,
Single.
and that's how we draw the structure. All right, with this I'll stop here, and as usual, we'll go to attendance.
So isn't it sigma alpha,
What do you mean sigma alpha?
the bond?
No, it is single and multiple, not sigma alpha.
Doctor, can you send the link?
Okay, go ahead.
Can you send the link, Doctor?
Oh, come on, you have it up on the. Okay, we'll send it as usual.
Doctor,
Yes.
the next test for chemistry, is it in 28 or 29?
28.
28, okay. On Saturday, not on Sunday.
I forgot one.
اوكي لانه في الرساله القديمه اللي جتنا 29 كانت حاطين 28 وحاطين اليوم الاحد عشان كذا احنا متلخبطين. هل ناخذ لان 28
I will check, double check now. I will send you on the WhatsApp the exact date, okay?
اوكي يعطيك العافيه.